So with that, I want to introduce tonight's presenters. As I'll be running the show as usual, Joe Deli Carpini. I'm the Science and Operations Officer. We also have Rodney Chai, who's one of our meteorologists. And tonight we have two of our lead meteorologists, Hayden Frank and Frank Nocera, who will be taking us through this event review. So with that, I'm going to hand it over. Frank is going to get us started with a look at what happened from the Derecho here in New York State and also, but mostly here in southern New England. So Frank, you can go ahead and take it away.
All right, thanks, Joe. If you just want to go to the previous slide with the radar image there, just want to show them what the radar looked like. Sorry about that. There you go. Thank you. So yeah, on the left image here, this is what the radar looked like about 6 p.m. that evening. Definitely not your typical radar image from October 7th. Pretty solid squall line racing through Massachusetts, northern Connecticut at this time, and those red polygons are severe thunderstorm warnings that we were issuing that evening. And again, really more typical that radar image of middle of summer, maybe July, definitely not early October. And you can see some of the damage on the right image there, and we'll show more damage images as we go through the presentation. So on the next slide here, we'll just look at what were some of the attributes during this, for this event. Well, we had a really strong jet stream leading up to this event. Winds up around 250 millibars, which is roughly about 34,000 feet, where most jets, planes fly. We had about 150 knots of wind on this day. And that's really strong for early October. That's really off the charts. It's more typical what you would see in the middle of winter, 150 knots at that level. So really strong jet stream, and then accompanying that was a strong cold front at the surface. So the two of those really played a role here in the damage and how widespread it was across the region. Sometimes this in the fall, in October especially, a lot of these events, they kind of lack the moisture and the instability. That's why these are very uncommon. But on this day, we had enough moisture for that squall line to develop and instability as well. And when we talk about instability, we're talking about how temperatures change with height. So on this day, temperatures were cooling rapidly with height, and we refer that to as lapse rate. So temperatures were cooling very rapidly with height, and that helped this squall line of thunderstorms to be very, very strong. And also the Storm Prediction Center, SPC, in Norman, Oklahoma, after this event, they went back, they looked at the damage, the storm reports, and concluded that this event was a derecho. And on the next slide, we'll look at the actual definition of a derecho. Basically, it's a widespread, long-lived windstorm that is associated with a band of rapidly moving showers or thunderstorms. It's commonly associated with straight-line wind damage. So if you were to look at wind damage in an event, like all the trees and the branches, if all the damage is laying in one direction, then that's straight line wind damage. But you can get brief spin-ups, brief tornadoes with these squall lines. Not very common, especially this time of year. But we'll take a look at a possible tornado in this event that we had. And again, here the last bullet, SPC. Again, the definition of a derecho, it has to extend the damage at least 240 miles and includes wind gusts of at least 50 miles per hour along its length, its path. And then it could be classified as a derecho. So this met the area of damage exceeded 240 miles. And we have a slide coming up to show you that wind damage. So what happened? Well, let's take a look. And here's that slide I was talking about. These blue dots denote wind damage. And you could see from the left-hand corner there where Joe has his mouse, the wind damage started around Lake Ontario and then just, rapidly moved across New York State into the capital region, Albany there, had quite a few, blue dots there, which means there's a lot of widespread wind damage. And right across the state of Massachusetts, and as most of us know, this squall line held together, held its intensity, and actually reached Cape Cod and Nantucket, where they had wind damage as well. So this whole swath of wind damage from Lake Ontario to Cape Cod and Nantucket exceeded that 240-mile threshold. So therefore, it was classified as a derecho. Not very common here in the Northeast, especially in the fall. Okay, and here's a radar loop out of the Albany area. The top left is reflectivity, so basically the intensity of the rain associated with the thunderstorms, and then the lower right loop is the velocity, the winds. And you can see in the top left corner here, the reflectivity, solid line reflectivity, so solid squall line, no breaks in that line, very strong line, and very tight reflectivity gradient on the front end, on the leading edge of it, so indicating strong thunderstorms. And in the lower right, where we have the winds, the reds are the winds moving away from the radar. The blue and the greens are the winds moving towards the radar. And we have some really high values there. So right along the line and immediately behind the line, there's some really strong winds associated with this squall line. And looking at our radar closer to home here in Massachusetts, you can see how this line of convection held together. Again, no break in the line, real solid, coming across the entire state, not losing any of its intensity. The yellow polygons are the severe thunderstorm warnings that we were issuing. And again, across the entire state, we even issued warnings for Cape Cod and Nantucket, and those warnings did verify. And then the blue polygons over the ocean are our special marine warnings. And this did have an impact too on the mariners. Again, it's October 7th, so a lot of recreational boaters still have their boats in the water. Typically, most people don't take their boats out of the water until after the Columbus Day holiday. So this had impacts not just over land, but also over the coastal waters. And this next slide here is showing you not the intensity of the thunderstorms, but actually the wind in the thunderstorms here. And the blues and the greens are the wind coming towards the radar, which is right where Joe has the mouse there. And you can see across Worcester County in the beginning here, these dark blues, they'll correspond to about 80 knots of wind. So that's extremely strong winds associated with these storms. And you'll see in future slides that we had about 50 to 60 mile per hour winds across the entire region. So definitely a high impact event here. Here are some pictures of the wind damage. And what's really amazing when you look at these pictures, it's across the entire state. Here we are in Weymouth, Massachusetts, in the eastern part of the state, just south of Boston. And these are just not small branches that are down. Look at some of the size of these trees that came down. So very strong winds. Large wind damage, and even here moving into Worcester County, really big impact, large trees, power lines down. I think the next image is here in Hingham, Massachusetts, more widespread tree damage. The next image, I believe, is in East Longmeadow. So across the entire state, from eastern Massachusetts to western Massachusetts, very widespread wind damage, and even more here in Millis, Massachusetts. And we'll talk more about Millis, about a potential tornado that took place here. And some more pictures here in Milton, Mass, near Blue Hill. Again, very large trees down, lots of damage, power outages, very extensive. Now, the winds associated with this line, very widespread. I mean, no matter where you look across the region here, we have anywhere wind speeds from 55 to 65 miles per hour. And many of these sites are not elevated. If you look here at Westfield Barnes Airport, that is 74 mile per hour wind gust. That airport is only about 250 feet above sea level. It's pretty close to the Connecticut River. So even places in the valleys really had some strong winds. And you typically don't see this. In the summertime when we have thunderstorms, sometimes, one community will get hit hard. The next community next door won't have much wind impact. But you could see here that, I mean, this was so widespread. There weren't too many communities that weren't spared. And I'm sure some of us on this webinar lost power or know someone that lost power. That's just how widespread this event was. And then here's the weather station at Mount Tom, which does have, some elevation here, but they did report a wind gust of 76 knots, which corresponds to 88 miles per hour. So really, incredibly strong winds, and not surprising the wind damage that took place. And as we were saying with these strong winds, keep in mind this is October 7th, so no matter where you are in the state, from the Berkshires down into Cape Cod, trees are fully leaved. So it doesn't take much wind to take down trees when they're fully leaved. And again, those reports of 55 to 65 mile per hour and even higher, the wind damage was really off the charts, and the power outages in the upper right-hand corner here, we have 246 outages that peaked at about 8 p.m. I can't remember the last time we had that many outages across the state of Massachusetts. So really high-end severe wind event here across the entire state. And we don't have the map for Rhode Island or Connecticut, but you can imagine that this, looked very similar, especially in northern Connecticut and northern Rhode Island. Okay, so making our way back to Millis, Massachusetts, we did do a storm survey. Our warning coordination meteorologist, Glenn Field, went out there and took a look at some of the damage. Before we look at some of those photos, we'll take a look at what the radar looked like as this line was going through Millis and the surrounding towns. The radar is actually in the southwest, or actually the lower right-hand corner of each image, okay? So the greens are actually wind that's flowing towards the radar, and the reds are away from the radar. So that little signature there on the front end of that yellow arrow, you have greens towards the lower right, moving towards the radar, the reds away. So you have a little bit of a circulation in there. And then as you go along in time, those greens get a little bit more pronounced. And what we call that is a rear inflow jet. So think of it as a stream of air that's moving towards the radar, but it's also descending down towards the ground. So you have an airstream that's actually sinking towards the ground, and that could produce straight line wind damage as well. But what it also does, it actually bows out the reflectivity, and that can be conducive to a tornado formation. On the next slide, we'll look at what it does with the reflectivity. And you can see as in time, as you go from left to right, you can see there's a little bit of a knob, or a reflectivity knob, or a curl or appendage in there. And that's where the tornado formed, right in that little curl or knob in the reflectivity. So when Glenn went out and did this damage survey, a few things that he noticed here was that this mailbox post at the bottom here, that's pointing towards or leaning towards the house in that direction. However, these trees and the branches that are down, they're actually at a 90-degree angle to that mailbox. So that tells that's a sign that this wasn't straight line wind damage, or else all the damage would be laying in one direction. But the fact that there's like a 90-degree, some of the damage is perpendicular to each other, that actually suggests there was some convergence there, which supports a possible, a tornado was likely in that area, and it confirms, verifies with the radar. So that's all I have now. I'm going to turn over now the model data to, I believe, either Hayden or Rodney.
Great, thank you, Frank. So we are going to go over some of the model data, and this is, what forecasters, what we look at to try to come up with a viable solution of what might unfold in the future. So this first image here, what we call a 500 millibar chart, and it's basically somewhat what Frank talked about, looking at the atmosphere, say 20,000 feet above the ground, so what things look like. And one thing you'll notice by Long Island and Chatham, Massachusetts, those are where the upper air measurements are taken. And you can really see the one on Long Island. Notice how there's two what look like triangles. Each triangle represents 50 knots of wind. So right there you can see there's two triangles there, so that's basically over 100 knots at 500 millibars. And when you have conditions like that in the atmosphere, you have very strong winds aloft. We typically get that, in the wintertime, in the fall. But what we don't normally have is something called instability, and we'll talk about that in a bit. So we can go ahead here and go to the next slide, and this will further emphasize the amount of wind. This is looking at 250 millibars, and that's equivalent, again, what Frank mentioned of, say, where an airplane may fly. You're looking at 30,000 feet off the ground, and what you'll see, if you remember the image he showed of where the bulk of the wind damage was from the Albany area through Massachusetts, right across the Massachusetts Turnpike, it's not a coincidence that you see that dark purple there. That's about 150 knots of wind. That's extremely strong. for any time of the year. Again, the winds tend to be a lot stronger as you get into, say, the late fall and winter. But this is strong no matter what time of year you're in. And what made this, again, different from other, say, events we have is something called instability. And we'll go into that a little more here. So this is one of our computer models we look at. It's called the HREF. And what it is basically an ensemble, a grouping of several high-resolution weather models. And basically, it's not like looking at one model, but like a set of models. So it kind of balances itself out. If one model's too strong with something or if one model's too weak, it can kind of give you, say, a consensus of all the models. So it's really a good way not to get too high or go too strong an event, or at the same token, dismiss a potential event. And we already know we had those very strong winds that we looked at in the past two images there. This is something called CAPE, and it's a measure of instability. To make it simple, basically the more CAPE you have, the better chance you have for thunderstorms and the better chance you have of, say, damaging winds or hail. Now, this is the probability of CAPE exceeding 500 joules per kilogram. And this is at 21Z. This is right when the event was getting underway. And notice you see those blue and greens. Those are 40 to, say, 60% chance of the CAPEs exceeding 500 joules per kilogram, which is significant in the sense that when you compare it to the amount of winds we had, say, at 20, 30,000 feet. That is 21Z would be, say, 4 or 5 o'clock Eastern Standard or Eastern Daylight Time. And let's go to the next slide, and you'll see that instability axis shift down towards Cape Cod and the islands. This is around, say, 7 or 8 p.m. that evening. And look at those high probabilities of CAPEs exceeding 500 joules all the way down to the Cape and Islands. Now, a lot of times, especially during the spring and the early summer, we see thunderstorms weaken as they approach Cape Cod and the islands. The reason for that is, well, the ocean may be in the 40s, maybe in the low 50s. But remember, it's early October, so that ocean temperature could be quite mild compared to even what is on land. In this case, it was still in the 60s. So you didn't get that cooling effect that you normally get from the ocean, which tends to diminish the threat for thunderstorms. Again, as Frank alluded to at the beginning of the presentation, for thunderstorms, you want the ground to be as warm as possible. And say at 20, 30,000 feet where airplanes fly, you want it to be as cold as possible. The greater difference in temperature from the ground to, say, that level where airplanes fly, the better instability you're going to get and the better chance of thunderstorms and damaging winds. So going forward here, we have high resolution models. I'm sure many of you are aware of, say, radar imagery. You may see it on TV. You may have phone applications now. There's a lot of those out there if you're outdoors at the time. But this is actually simulations kind of anticipating what the atmosphere may look like at specific times. So this is around 4 p.m. that afternoon. And what you'll notice is an area of enhanced, what we call reflectivity. That's where you may see heavy rain and thunder just approaching the Boston to Providence corridor there. And then you'll see another cluster, say, up into New Hampshire and Vermont, the southern portion of those states. Now, these models, they're just simulations. They're not perfect. In this case, they gave a clue of what might happen, but they weren't intense enough with the thunderstorm activity. And there's different simulations. Now, this is another simulation from one of our computer models. If you compare it to the other model, the last model we looked at was a lot more robust, had a lot better idea of what was going to transpire. If you look at this computer model, it really just looks like a few showers crossing the region. So this model was underdone, and that's the importance of not putting all your eggs in one basket in one computer model and kind of looking at all the models and then kind of coming up with a forecast based on a range of possibilities. And that was what the advantages of looking at an ensemble, a clustering of weather models and comparing instead of just one specific model, which could be misleading. And this is another model here, another high resolution model. You can see it, again, it was underdone with the intensity, but this was around 4 o'clock. Notice there was a lead area of showers approaching the Boston to Providence corridor at that time. I live in central Massachusetts. We actually had a brief cluster of just rain showers with some wind out of it, and then we had a break. I know that because my son had a baseball game, and the coach was hoping to play, and I had to tell him, well, we got another big line of thunderstorms coming into northwest Massachusetts, and that was the key player. So it actually kind of simulated what was going to happen, although it did underestimate the intensity. And then here's another model as we get towards 6 p.m. This is something called the HRR model. This did the best with it. Again, this model's run every hour, so it can pick up on various changes where some other models are only run, say, 2, 3, 4 times a day. But you can see right around 6 p.m., those dark reds, and when you see dark reds, that's a good indication of showers and embedded thunderstorms right along the Boston-Providence corridor. So that model really did the best with the intensity. And now for the real-time mesoanalysis section, I am going to pass it over to Rodney.
Thank you, Hayden. Let's take a look at what the real-time atmosphere was like during the Derecho event. Remember what Hayden talked about, that was the simulation. So that's not necessarily what transpired. So taking a look at 3 p.m. mesoanalysis, and when we talk about mesoanalysis, that's just a scale that we use in meteorology. You may have heard of terms like synoptic, mesoscale, global, and mesoscale analysis is appropriate when we want to look at the Northeast in general, stretching over hundreds of miles. So in this case, and as Frank and Hayden have alluded to, because this is a late season event, in the summer, the CAPE, or the convective available potential energy, which is the amount of fuel that is available for thunderstorms to develop, it's more readily available earlier on in the summer, because you get a combination of high temperatures, temperature in the 80s, and high dew points, which is a measure of moisture in the atmosphere. Dew points in the 60s are usually more favorable for the development of thunderstorms, and especially severe thunderstorms. So being later in the season, the temperatures that day was not that impressive. It was only in the 60s. Dew points were even less impressive, only in the 50s. So you would think that this is not a setup for severe thunderstorms. But the devil is in the details. So instead of looking at how much instability there is throughout the entire atmosphere, we look at how much instability there is in the lowest 3,000 feet of the atmosphere. So that is, in this case, we're going to look at the 0 to 3 kilometers ML CAPE, or mean layer CAPE. So in a nutshell, that's the CAPE at the lowest 3,000 to 5,000 feet. In this case, we noticed that there's actually enough instability in the lowest part of the atmosphere. And as we step through the slides, you will focus your eyes on the 100 contour lines. When we look at values of 100 joules, which is a unit for CAPE, notice that the swap of 100 steadily advanced to the south and east. And that's what helped the line of thunderstorms to sustain itself all the way from New York State to the Cape, and that's very rare for any time in the severe season. Never mind it's early October, so late in the season. So remember Frank and Hayden talked about there's 150 knot wind at 30,000 feet. We have that screaming upper level jet, and the question is there enough instability to spark off severe thunderstorms? And the answer is yes. And so that's why we got the Derecho, and turned out to be one of the most highest end severe event of the season. So in summary, again, this is a very rare high-end severe weather event for southern New England. It's rare enough any time of the year, never mind early October. And one of the things that stood out to us as forecasters is that almost all the automated stations record 70+ mile per hour gusts. In a severe thunderstorm, usually, we want to see 58 mile per hour gusts and above to verify a warning. But most often than not, it's hard to have any station record 58+ mile per hour gusts. So we rely on the storm damage, like wind damage, to verify a warning. But in this case, the automated stations, that's 70+ mile per hour gusts. That's more than enough to verify a warning. And to recap, the storms form as a result of enough instability at the lowest 3,000 to 5,000 feet, combined with impressive dynamics, that 150 knot wind at 30,000 feet. The original forecast concern was that there's not going to be enough instability to generate a line of storms, never mind severe thunderstorms. But as we went through the meso analysis, that concern is not really a concern, and because the other scenario would be, in the absence of a severe line of thunderstorms, you would have strong winds regardless because of just 150 knot winds at upper levels. So, it doesn't take much for some of the winds to mix down, and then you get 50 mile per hour wind. And that's why, if you remember, we have a high wind warning for pretty much most of southern New England. And then last but not least, there was an embedded EF0 tornado that touched down in Millis, Massachusetts. And given the widespread straight line wind damage, it is very challenging to discern, tornadic damage within a swath of straight line wind damage. And remember, straight line wind damage, everything kind of fall in one direction. So it takes not easy to find a tornadic signature in a few of straight line wind damage. So I think that's all that we have. Thank you very much for your time, and I will pass it back to Joe.
All right. Thanks, Rodney, and Hayden and Frank. We'll go through. We've got a few questions in the box. And the one other point I'll bring up about that tornado in Millis was it was actually the radar imagery that kind of clued us into the fact that the tornado occurred. As Rodney said, it's very difficult to tell when you have widespread wind damage. Was there actual tornadic damage within it? And we had a lot of reports of, significant wind damage, and a lot of people messaging us, telling us, they may have had a tornado. And we were actually able to go back and look at the radar data to determine whether or not there was, more than the tornado just in Millis. And it turns out the radar really didn't show any other strong rotation signatures. So we were able to rule them out elsewhere. So thanks to the radar for helping us out on that one. So just a comment from Will. I will never forget this storm. It was very unexpected. I watched the event develop throughout the day on my radar app. Then around 6:30 p.m., the derecho slammed into my house. this was the first derecho I've ever witnessed. Very rare any time of the year in southern New England, but especially in October. And that's certainly true. And I think, Hayden, you may have to help me with this, but I believe the last derecho we had in southern New England was back in May of 1998, May 31st. So am I correct or am I wrong?
Yeah, Joe, I think technically there was one in 2006. It was a relatively smaller scale one, but it went like all across Massachusetts. It was during an intense heat wave. I can't remember if it was July or early August, but it actually was classified as a derecho.
Okay, I stand corrected. That's why we have you come to these webinars, because you know all the dates. But I know prior to that, there was May of '98, and also July of 1995 was a very widespread derecho from the Great Lakes all the way to New England. So, but good. Okay, so it's 2006, so about 14 years. Question from Samuel: can derechos be forecast ahead of time, and would there be a specific derecho warning issued? I'll throw that one out. Frank or Hayden, you want to grab that one?
I can take it. Basically, there are ingredients we look for potential derechos. They can be forecast. It's often a difficult task, especially with their location and intensity. Normally, for a derecho, the parameters are in place. The instability we talked about is normally higher than what we saw during our event, but it can be compensated for. And in this case, as Frank showed early in the presentation, the very unusually strong winds at say 15 to 30,000 feet were able to make up for the limited instability. But to summarize, we can forecast the potential for derechos, but again, the exact location, the timing, and the intensity are often difficult, and some are easier than others to forecast.
Yeah,
if that makes sense.
It's almost, you have to see the whites of its eyes. We know it's a thunderstorm day, maybe a line of storms, but things have to come together just right to get a full-fledged derecho to occur. So it's almost as it's unfolding, maybe a few hours before at best, that we would know. And as far as a specific warning, we issue severe thunderstorm warnings. The good news is, obviously with the derecho, we'd be mentioning higher wind speeds, sometimes 70, 80, 90 miles per hour. And coming soon, I believe, and Frank or Hayden, you can correct me on this too, the cell phone alerts will be triggered for those higher end severe thunderstorm warnings. So that would be the way that the warning would get out to everybody. I believe that's correct, guys, right? I don't think it's active yet, but it's coming.
Yeah,
I think it's coming.
Yeah.
Just not sure on the exact timetable.
Yeah, I know there was a delay because it's run by the FCC, but it's in progress. So hopefully by next summer.
And I think it would be for wind gusts over hurricane force over 74 miles per hour.
Right. So
is
right,
yeah.
And in that case, and in this case too, the warnings included that kind of those kind of wind speeds. So you would have it a severe thunderstorm warning, but what we call a higher end one, where you'd be alerted on your cell phone. So good question. Okay, from John, Mount Tom Range has a steep drop off on its western side. Could that have contributed to the wind speed measured there? Who wants to take that one?
John, this is Rodney.
Sure.
That's a great observation. But I think that the major factor was really because of the higher wind speeds aloft in this case. We talked about at 15, 30,000 feet, that's 150 knot winds. But when you get down to, say even 1 to 2,000 feet, you have 80 to 90 knot winds, and that's just because the weather instrument is at that elevation, so it's able to actually measure the higher wind speeds at the higher elevations.
Right, and I think a similar thing was seen at like the Worcester Airport as well. It's just higher than the surrounding wind gusts. But Good question. Okay, from Joe, the SPC had a marginal risk for the day. Seeing that it was a derecho, would this fit in as a high risk category if the SPC was forecasting the threat of a derecho developing? Hayden, do you want that since you coordinated the marginal risk?
Sure. Exactly. So because there was uncertainty in the amount of instability, whether or not severe weather materialized was a bit uncertain. Were we going to see, showers without lightning with damaging winds, or, obviously what we got was a full-fledged derecho. One thing to keep in mind that the term derecho, as Frank went over at the beginning, is a specific definition, for a required aerial coverage of damaging winds. You can have a high-end, severe thunderstorm event where it doesn't technically qualify as a derecho, wouldn't be classified as a derecho, but you have a lot of wind damage and a lot of power outages too. So I think it's important not to get caught up in, whether it was a derecho or a significant severe thunderstorm event. Obviously, derechos are usually more significant, but you can have, a big severe weather outbreak without it being classified as a derecho. But the reason why in this case, it was because the instability was on the fence of being, whether we'd have enough instability for a significant severe weather outbreak. And if you go back, I don't know how many of you are aware that the derecho that occurred in Iowa over the summer, again, it was one of those situations where there were some ingredients in place, but the location and obviously the full-fledged intensity was unknown at the time. So, these are really tricky to kind of, pin down the specific area and the specific intensity. But at the same token, we can still give an idea of where there may be a potentially high-end severe weather event. And we are also, given that those high-resolution models, we're able to do that a lot better than we were even able to 7 or 8 years ago.
Right. And my guess, Hayden and Frank and Rodney, is if say on, that morning, you were expecting, like a high-end severe, maybe squall line type event like this, we probably would have had I would say maybe an enhanced risk, not that as much, enhanced high, but, I would think probably if our confidence was high, we might have seen like an enhanced risk or, maybe even slight, something like that. That's pretty typical.
Exactly. We would have seen an enhanced. And if you remember back, the first severe weather outbreak of the year, it was one of our most significant ones up until this event, was on May 15th. It really affected northern Massachusetts. We were in an enhanced risk, and it was being played up 24 to 48 hours in advance, where we had higher instability and we had pretty good wind fields, at say 20, 30,000 feet. And we were able to, relay that information that we were going to have potential for a significant severe weather outbreak across northern Massachusetts. Now, again, that resulted in a lot of power outages, not as extensive as this. It wasn't didn't meet the threshold of a derecho, but it was a significant severe weather outbreak, especially if you were one that had damage or lost power.
Okay. Joe, good question. Thanks for sending that one in. Question from Joan. Was there time to warn people of the potential damage? Maybe Frank, you want to tackle that one?
Well, for the state of Massachusetts, and I know we talked about this, I mean, they were in a high wind watch and then a high wind warning. So we know in the state of Massachusetts, the utility companies were able to reach out, 12 to 24 hours in advance and get some extra resources from surrounding states. And that actually led to power restoration being probably within 24 hours after the event. Quite a few people got their power back in Massachusetts, but in Rhode Island and Connecticut, they didn't have the same level of warning because we weren't as confident. We were more confident it would happen in Massachusetts. and therefore we only had advisories in Connecticut and Rhode Island. And for those reasons, the utility companies there weren't as prepared, and some places in northern Connecticut, northern Rhode Island didn't have power up to 5 days. So I think the warning was pretty good in Massachusetts, and that helped a lot of communities get their power back within 24 hours. So I hope that kind of answers the question.
Yeah, I mean, I think so. The word was out, the day before, so to the emergency managers, and there were email briefings going out from our office. So, and then for the general public, the severe thunderstorm warnings that day, I think, helped raise awareness. The TV meteorologists were able to get on the air and show that information too. So, my vote would say yes, and I'm not being biased here because I work in the office. All right, good question, Joan. From Ronald. This is an interesting one. Do you think there's any connection between this tropical season's intensity and the October 7th derecho? I would say it probably would be very difficult to set up some sort of linkage. I don't know at the time, and Hayden, you're going to have to remind me as the guy who remembers all the events. I don't believe there was any tropical activity just prior to this in the Gulf, was there?
Yeah, I can't recall myself. But whether there was or wasn't at the specific time, or a couple days before, or a couple days later, it'd be really tough to be able to quantify that. You couldn't do it on one case. You'd have to have a whole study over the last 25 years to be able to, say that was the cause of it. And actually, I don't want to get off topic, but one thing that was discussed about in this event, there were ingredients that were coming together. We were very concerned. We had a fair amount of confidence that there would be damaging winds, but we weren't sure if they would be more driven by thunderstorms or more like the winds we had today. So even though the lead time on the widespread thunderstorms wasn't maybe as great as we would like, we were able to get the word out through a high wind warning and high wind watch the previous day or two. So folks were prepared for it.
Okay.
Yeah, the only thing I would like to add to that, Joe, is it's a good question as far as the tropical activity, and I agree with you guys. It's really hard to make the connection, but if there was any connection, I think it would have to be tropical activity in the Pacific, because those storms out there, whether there be typhoons out in the far eastern Pacific or western Pacific, that sometimes builds the big ridge out in the Pacific, and then you could get a stronger jet across the CONUS. But that correlation isn't that strong. But again, it goes back to, I think, the tropical activity being in the Pacific, not necessarily in the Gulf, that could strengthen the northern stream jet.
Right. Yeah, good point. And that's actually something we look at for winter storms sometimes too, early season ones. Okay. From Benjamin, was there a derecho in Chicago? The answer to that is yes. That was the Iowa derecho that Hayden was talking about before. It started in Iowa, raced across through Chicago, and ended in Indiana. So that was over the summer. Comment from Jonathan. Did see some very strong winds here in Stafford, Connecticut, along the Massachusetts border. Lost power for a while as well. And Jonathan, I would say you probably were not alone in that regard, but good to know. Yeah, that definitely was a very much a widespread event which affected Connecticut and Rhode Island too, especially the northern parts near the Massachusetts border. From Gabriel, I was not expecting to see severe thunderstorm warnings on my NOAA weather radio in October. Thank goodness for NOAA weather radio. Hey, how about that, guys? There are still people, and this is a good commercial for NOAA weather radio. We have cell phone alerts and TV, but if power goes out, a NOAA weather radio that has battery backup is a great resource for getting severe weather information. So, Gabriel, hats off to you. You guys have any comments or add anything? All right. Nothing for the weather radio, huh? We still run it. And that is 24/7. You can get those at most, you can get it online or at most radio type stores. Electronic stores have them. So, again, battery backup is a great thing because that will provide you weather information, severe weather information if the power should go out. So, thanks, Gabriel. From Ethan, do derechos often have high outflow winds that are miles ahead of the actual line of storms? Asking because I like to fly drones to get severe weather pictures and videos, but I don't want my drone to be blown away as I usually just land before the actual precip arrives. But outflow winds far ahead would make it difficult to get footage safely. Who would like to handle that? Hayden, Frank, Rodney?
Sure. I mean, I think the question was, thunderstorm winds out ahead of the main activity.
Correct. Yeah, he's asking, do you get the high outflow winds miles ahead of the actual line of storms because he's concerned about getting his drone to land safely before the storms hit?
Sure. You can do that. We've had it here. It usually happens even a few times a summer. But when the outflow, the winds get too far away from the actual thunderstorms, usually you'll see a weakening trend because you get that cool air outrunning the thunderstorms. So you can get 40, 50 mile per hour wind gusts and damage, 10, 15, 20 miles outside the thunderstorms, maybe 15, 20, 25 minutes before you see any rain. But you're usually not going to get the meat of it, the real big damage. Like in this case, the winds held back with the thunderstorm line. So if things had raced out ahead of it, the winds wouldn't have been as strong. I mean, you would have had some damage, but not like we ended up with.
Right. So, Ethan, for the most part, it's going to be right along with the main line of storms for the stronger cases anyway. So, hope that helps. Another one from Joan. How does one get on the cell phone alert for these high winds in the future? It'll be automatically done, Joan. Again, I mentioned these higher end severe thunderstorm warnings. So right now on cell phones, you get them for tornadoes and flash floods. So the FCC will be adding these higher end severe thunderstorm warnings in the future, hopefully by next summer. I know it was delayed, but should be early next year. So stay tuned for that. From AJ, do we know how the winds at 500 or 250 or the temps at 500 millibars ended up relative to climatology for early October? You guys have a handle on that since you probably forecasted this more than I did?
Joe, this is Rodney.
Yep.
I can answer that
Sure.
question. So AJ, the 150 knot wind at 250 millibar or 30,000 feet is it's actually higher than the climatology for Chatham, Massachusetts. That's the site that we use for SPC sounding climatology. The typical value for early October is actually 60 knots. The 90th percentile is around 110 knots. So 150 knots, that's actually way off the charts. That's pretty much like a midwinter jet stream. So with that kind of jet energy, the question is, would there be enough instability near the surface to tap into? And there was. So that's why we have this high-end severe weather event.
All right. Yeah. So the short answer is yes. This was, as Rodney likes to say, off the charts. So when Rodney says off the charts, I know something big is coming. But yeah, highly, highly anomalous. Good question. Another one from Ronald. There seems to have been an uptick in October severe weather the last few years. Any thoughts? Hayden, you're a severe weather guy.
Yeah, we actually had a couple of events, including several tornadoes back in 2018 in October. Again, it's you have to have more of a case study going back, say 20, 30 years to be able to really kind of build a trend. It's also important to note that, we get more reports now than we did, even 10, 15, 20 years ago with social media. Everyone has a cell phone where they can, record things now. So there's that to take into consideration too. That being said, I don't think it's a reach to say that severe weather threats are increasing, maybe slightly at least, later in the year, because our ocean water temperatures are warming, and you actually can do a correlation on that and see how they've warmed, say over the past 20, 30, 40 years. And that makes a difference because one of the factors in instability is not only temperature, but a bigger player is the dew point, which is the amount of, say, moisture in the atmosphere. And warming the ocean a couple degrees, it may not sound like a lot, but it increases that dew point and can have a significant role in the amount of instability that's able to be generated. So again, you'd really need to prove it beyond say a reasonable doubt. You'd really have to kind of put together a bunch of cases. And what the difficult thing in this is that we have so many more reports now than we used to be, which is great. Great spotters, great network, but that's another difficult thing that would be tough to really prove.
Yeah, actually, Ronald, I know there was a study back. This was the early 1990s. They looked at the Carolinas and the kind of the Mid-Atlantic area, and they actually found there was like a secondary severe weather peak in the fall. And I think, Hayden, that probably makes sense now with the oceans warming, as we know, that maybe that area is shifting a little bit further to the north too with time. So, like you said, it's partially probably more reports that we have, but there's probably something to that. I remember seeing research back in the early 1990s on that for the Carolinas. So, good question. All right, from Brian, what time of year is this sort of event likely? Is it possible to get something similar in winter? Who wants that one, guys?
Joe, I can try to answer that
Okay,
question.
sure.
Yeah. So in a nutshell, in winter, it is very unlikely to have this kind of severe weather event. In fact, really any kind of severe weather event, because simply the temperature is too cool for severe weather. It's, in generally you like to see at least like 60, 70 degrees temperature and dew points in the 50s, although severe weather can happen with dew point in the 40s. In fact, last winter, actually, we issued our latest ever severe thunderstorm warning in the calendar year on December 30th, in the middle of an ice storm. Some of you may remember, especially in western Massachusetts, there were reports of quarter-size hail in the middle of an ice storm, and there was also thunder reported as well. So you can call it thunder ice or thunder freezing rain event. But in general, in winter, very unlikely to have severe weather. And the other part of the question is about what time of the year, do we typically get higher end severe weather events? I would say for southern New England, it's earlier on in the spring. So if you remember some of our higher end events, the middle of May. And the reason for that is because, we talked a lot about the temperature and dew point temperature, but the other ingredient is you want a strong jet stream, and you only get a strong jet stream when there is a big difference in temperature, in the higher latitudes. So I think about Canada and the Arctic, and then you have warmer temperatures from the tropics. So when you get a big difference in temperature across, from north to south, that enhanced the jet stream. And in this case, we had the 150 knot jet at 30,000 feet. That was actually fed by, we have very cold air to the north and warm air to the south. So typically you get severe weather in the spring. So think about, Midwest, Kansas, Oklahoma. You get that temperature difference in the spring, and then you get the secondary severe weather season later on in the fall, because it's that temperature difference starts to increase between the Arctic and the tropics. So in general, either earlier in the spring or in the fall, but early October, that's kind of late in the season. So this is indeed a more kind of a rare event for severe weather.
Okay. Thanks, Rodney. Just a few more questions from Gabriel. How far into the ocean did the storm go before it weakened? I believe it was just after it crossed the Cape of Nantucket and got a little bit offshore, Hayden, if I remember.
Yeah, it did weaken as it quite quickly as it exited the Cape and Nantucket areas.
Okay. From Luis, this derecho displayed a more discrete, what he calls tail end Charlie cell in Waterbury. Why is there often a more discrete storm at the southern end of the line? Want to grab that one, Hayden, since you're a severe weather guy?
Sure.
Okay.
Yeah, so basically, it has no competition if it's the last storm on the line. Thunderstorms, we like to say, like inflow, air going into them, moisture going into them. And on the south side or the southern edge of a storm, a complex of storms, if you're to the south, there's no rain cooled air getting sucked into the thunderstorm. So that often has the potential to become the most significant storm in a cluster or a line of thunderstorms. In fact, those of you who are familiar with the June 1st, 2011 tornado outbreak, that the long tracked tornado that went from Springfield to Munson, there were actually a couple other earlier tornadoes in that general cluster, but the big one became the one on the south end. And I think it's widely believed that because it was on the southernmost area, there were no other storms to the south, so it was able to completely hog all the inflow moisture coming up from the south with no interference. So it's not uncommon to see that storm on the southern portion of the line or southern cluster become the big player.
All right. Thanks, Hayden. Couple comments from Ronald. We're going to hire him as an advertiser for NOAA Weather Radio. He has two NOAA Weather Radios, one for my home, one for the car. Automatic warnings on the cell phone, the best thing since sliced bread, but you still need a NOAA Weather Radio. Thanks, Ronald. We'll send the check on the mail for you for advertising NOAA Weather Radio. Gabriel just wants to know what's considered a high-end severe thunderstorm warning, and I think Hayden mentioned that before. Essentially, gusts that are hurricane force or greater. So, in excess of, for the most part, we say in excess of 70 miles per hour for that. And the last one, we'll give the last one to our friend Luis here. Wind shear creates favorable environments for tornadoes, but poor ones for hurricanes. Does a global reduction in shear this year explain our record hurricane season and the relatively low number of tornadoes? Good question. Do you guys want to handle? One of you guys going to handle that?
Yeah, Joe, I think I would.
Okay, Rodney, go ahead.
Give a partial answer to that.
Sure.
So I think, in my opinion, the bigger driver is really the warmer ocean temperatures. That's the main ingredient for, maintaining the strength of a tropical system and its subsequent intensification to a hurricane. As for wind shear, that's a really interesting observation. I personally, I'm not aware of any research that has looked into the relationship between the wind shear in recent years and hurricanes. So I would just leave it to my colleagues to see if they have any insights on that.
Yeah, what I was thinking, Rodney, was, you're looking at two different scales. So, hurricanes the wind shear is on a very large scale, whereas tornadoes, it's on a more localized scale. So, does one have something to do with the other? Probably not. We're looking at shear for hurricanes. It's down in the tropics, essentially, whereas, tornadoes are at the higher latitudes where you typically have more. So, again, you're looking at two different scales. So I don't think you can compare both, but, something that I'm sure someone in the research community may end up taking a look at sometime. So, Good question. Frank or Hayden, anything to add on that?
No, I think you covered it, Joe.
All right. All right, guys. Again, I want to thank Hayden and Rodney and Frank for joining us tonight for this event review. Again, we'll have it posted on our YouTube channel if you want to go back and watch it again, or if someone you know didn't get a chance to attend tonight, you can certainly go back and tell them to look there.